Python is a wonderful programming language that is often underestimated because it's so clear and simple. People mistake this simplicity for being too simple for real programs. After all, you didn't even struggle to get your program to link against an incompatible static library or battle a DLL version mismatch in your Python app at all today, did you? Usually we find this simple and clear programming language to be powerful and fast. But what happens when it's not fast enough? Do you have to stop and rewrite your code in C, C# or Java? Well, before you do something drastic, Mike Mueller is here to teach us the techniques and steps to determine why our Python programs might be slow and give us some tips to make them faster. This is Talk Python to Me, episode 66, recorded Monday, July 4th.
I'm a developer in many senses of the word, cause I make these applications, but I also use these verbs to make this music. I construct it line by line, just like when I'm coding another software design. In both cases, it's about design patterns. Anyone can get the job done, it's the execution that matters. I have many interests, sometimes.
Welcome to Talk Python to Me, a weekly podcast on Python, the language, the libraries, the ecosystem, and the personalities. This is your host, Michael Kennedy. Follow me on Twitter where I'm at mkennedy. Keep up with the show and listen to past episodes at talkpython.fm and follow the show on Twitter via @talkpython. This episode has been brought to you by Rollbar and SnapCI. Hey everyone, it's great to be with you today. I have a couple of news items for you this week. First up, Stitcher. If you've been listening to Talk Python to Me on Stitcher, I have some news for you. Unfortunately, due to some business practices that I believe are harmful to the podcasting space in general, I've asked them to delete my listing and remove the show from Stitcher. If you're unfamiliar with the service, it's basically a podcasting client, but instead of just serving up my content from my servers like most players do, unmodified, Stitcher downloads my MP3 files, re-encodes them into a low bandwidth format, and then slices it apart and inserts their own audio ads into my show without any form of revenue share whatsoever. I don't get a penny from them for this. To me, this is unacceptable. I did a big write-up about it, and you can find the link to the write-up in the show notes. The article was entitled Stitcher and Talk Python Podcast, a farewell letter. Next up, on a positive note, a review. I want to say thank you to Jamal Moyer, who did an excellent review of my Write Pythonic Code course called The Course Everyone New to Python Desperately Needs to Take. It's an interesting view on what's good and what's not so good about my course. I gave Jamal access because I was interested in his opinion. I didn't know he'd write a review, but I'm really glad he did. Thank you, Jamal. You can find the link to his review in the show notes. Jamal actually has a bunch of great Python content, so I encourage you to go check out his site. Now, let's hear from Mike about making Python programs faster. Mike, welcome to the show.
Hello.
It's great to have you finally on the show. I've seen a lot of your presentations, and I've always thought that they were really great. And today we're going to take one of your PyCon 2016 presentations and sort of have a conversation around it about making Python programs faster.
Yeah. Very, very nice to have me on the show. I listened to most of your podcasts, very, very interesting. So it's an honor to be here.
Oh, well, thanks so much. Well, let's get started by sharing your story. How did you get into programming in Python? I know you've been doing Python for a long time, right?
Yeah. Actually, I pretty much know. I started Python in 1999. So I worked on my PhD thesis. And the task was to couple numerical models. We had existing numerical models. One was written in Fortran, one was written in C. And I looked for a language to couple. I knew I'm not going to write it in Fortran or C. I just want to have something else. And I looked at different languages, Java and other things. And then I somehow hit Python. And I asked on a mailing list, it would be a good language to couple things. And then I got a call from Martin von Löwis. He's a Python core developer now for quite a while, and he just talked me into Python. And that's how I got started. So I used it for my PhD thesis and coupled models, and I got it to work, which was not really clear if this would work because there are numerical models from different fields. And I put them together and made them work as one model, as one program, and it worked out pretty well.
Oh, that's really cool. What was the subject of those models?
So actually, my background is hydrology, though I coupled a lake model with a groundwater model and a hydrogeochemical model. So you have this after mining, you do surface mining. And then you take something out of the subsurface, which is the purpose of mining, and then you have a void left, and this void typically fills with water, with groundwater, and forms a lake. Now you have this what's called a pit lake. And a pit lake is pretty different than a natural lake in terms of water quality. And that was the purpose, to find out the water quality of this lake. And though I had a couple this lake model, which kind of takes care of the lake itself, and the groundwater model, which takes care of the groundwater part, and the hydrochemistry, which is pretty different from a lake model. Typical lake models are very different systems determined by algae growth and stuff like this. And now this lake is different because you have these chemicals going in there. Actually, you have a very acidic lake most of the time. That depends on the nature of this thing. So if you draw down the groundwater table, there are some chemical reactions going on, and they take things out of the subsurface, and then the groundwater moves over the stuff into the lake. And you have a very acidic system, which is very different than the natural system. That's what I was working on. And for this one, I need a new model. And I cuddled it, and I did it with Python, and Python worked out very well for this.
Was it controversial or a big risk that you took to try to do this with Python?
No, I was pretty free. So in academia, just the end result counts. Nobody really was into programming. All these people are experts in groundwater and lakes and stuff, but the programming part, I was pretty much on my own, and I could decide whatever I want, and nobody asked how I do it. Just as long as it works, it works. Yeah,
that's cool. Yeah, I suppose probably the major alternatives were things like MATLAB or not other programming languages necessarily.
Yeah, yes. You look at different systems, and first you have to get into this, how you're going to do this, and then you say you can extend Python with C, and then you can connect C to Fortran, and that's how I did it, actually. I wrote, at this time, we didn't have tools yet, at least I wasn't aware of. This F2Py tool, which I use now regularly, didn't exist yet, so I wrapped every single subroutine in Fortran with C, and then every single C function with Python by hand, which is a very tedious undertaking.
I can't imagine, but you probably learned a lot doing it, right?
I learned a lot. I learned a lot about the C API, and I tried to keep it very simple, which was still complicated enough because for every function I had to study this, how to do it, and looked at some examples. And this time we didn't have Stack Overflow or anything like this. Everything was just, if you email us, if best, and everything was much slower than nowadays in terms of getting help from the internet.
Yeah, absolutely. Learning to program or learning the right techniques was completely different back then, wasn't it?
Yeah.
Yeah, cool. So we're going to talk about making Python programs faster.
Yes.
And that's you did a really great presentation of that at PyCon, and we'll kind of go through the details there. But in general, how much does performance matter? Like on one hand, it might be great to have faster code, but on the other, maybe we just get more VMs or pay a little more for our cloud bill or something like this.
The answer is the clear depends. It very, very depends what you're going to do. For a lot of people, Python is plenty fast. So I think for most cases, actually, Python is pretty fast. For most web developers, as I talk to them, and they're pretty happy with it because most of the time the database or the network or something, it's what causes the problem. Most of the time, Python is fast enough for this. But I also teach a lot of scientists and engineers, and depends what they're doing. If they just move data from A to B, then Python might be fast enough. But if you do real simulations, then Python is way too slow for a lot of things. So it depends very much what you're doing. And if they have the right case, then you need to do something to make Python faster. That's one thing. But having it faster is always a good thing. Typically, faster is better than slower. And sometimes it doesn't take a lot of effort to make things faster. That's one case. So sometimes it's just making things a bit nicer, and as a side effect, making it faster. And the other thing is you put a lot of effort in to make it faster. So you make it actually more difficult to understand, but you make it faster because you need it. I think these are two areas here.
Yeah, I think you're right. Certainly the computational stuff is really, really important. And I suppose with the websites, it depends a little bit if you're a web developer on what is fast enough and how fast you have to be.
Yeah.
There was a really interesting study, I think it was by Amazon. It was something around like the price of latency. And it said something like for every 100 milliseconds that our site is slower, we lose, some percentage, like several percent of business. Maybe something like 1% or something of business. And, if you have a lot of traffic, that also really matters, right?
Yeah. So performance matters. Just a question if Python is the one that is a bottleneck for the performance. It's not totally clear. There can be many other things that cause your site to be slow. It doesn't have necessarily the programming language. There can be other considerations.
Absolutely. For example, if you've got 1 million records and you're doing a non-indexed query on your database, it probably doesn't matter what language you're using.
Yeah.
All right. Cool. So let's talk about your tutorial. What was it called?
Yeah, it was faster Python programs, measure, don't guess. So you should stress actually on the measuring part. I started out, I think in 2007. It was my first 2 tutorials at PyCon US in Dallas, Texas, my first PyCon, and I gave 2 tutorials right away, which was amazing. And actually it was a 2-part one. The first one was more or less what I have here, the measuring, and the second part was actually extending Python with other languages, so like C extensions and using other tools there. And now it's just the first part, and this is stress actually on measuring, just getting a grip on your system to find out what's going on and where are potential points to improve. I think it's very important to have something to quantify what's going on and see where the problems are, and then maybe come up with a solution. And that's very important to measure things and to make it quantified. You just have a gut feeling it's slow and have to do something. That's not really going to work.
Yeah, I totally agree. When I started out doing professional programming, I did sort of scientific visualization tools. I found that lots of people, including my intuition, was really quite wrong often about what was fast and what was slow. Maybe have like some really complicated like wavelet algorithm. You think, oh, this has got to be just super slow. And some other place where you're just working with a basic data structure. And it turns out like the majority of the time you're fiddling with the data structure or something like this, right? So this measurement idea is really important.
Yeah, so I can confirm that I do it for quite a while, and most of the time I have a kind of feeling what's going on, but very often actually I'm wrong. So for some reason there's something else I didn't think about it, which is very clear afterwards. You say, of course, that's the reason, but you didn't think about it beforehand.
Yeah, and that's coming from somebody who spent a lot of time doing this optimization, right?
Yeah.
So even with the experience, sometimes it still can be hard.
The experience helps. It helps, but it's no guarantee that you get it right. So you have to measure.
Right, and of course you can look at code. You can say, well, I'm sure that this version of that code is faster and this version of the code is slower. But if it's 10 microseconds versus 20 microseconds, like who cares, right? It really matters how you're using the code as well. So one thing I thought was interesting when you talked about your PyCon tutorial was that you said, we're going to use Python 3. And I've been on a big push to like evangelize Python 3 and so on lately as well. And what was the reason you said it?
Yeah, so of course, I think you have Python 3 and you have legacy Python. So I would like to use the current version of Python 3. Because I teach Python for a living, and I always use Python 3 whenever possible. Because when you're outside in the real world, there are still a lot of systems running 2.7. But still, I like to use Python 3 for teaching and show that's a nice way to do it. And if you want to do Python 2, then it's not that difficult to write programs with the same source code that run with Python 2 and Python 3 if you just take a few steps. So throw out all this deprecated stuff in Python 2, and you're mainly there. Import from future print, something like this, and then you are there. So most of the things you can write, and that's why you're ready to run in Python 3, and you still have to support Python 2 for some reason, and you still can do this. And that's very important because otherwise you might redo a lot of work later on when you now kind of focus on Python 2.7, even though all your colleagues are still on 2.7.
Yeah, absolutely. I agree with you. I think that's great. You know, from futures import, was it Python, print function, and then maybe range equals X range. If
those kind of things.
Those kinds of things. And then you can write your Python 3 code in a way that is compatible with Python 2, long as the other way you can get yourself more into trouble, I think. Yeah, very interesting.
The PyData Berlin, I just gave a tutorial about writing code that runs with Python 2 and 3 at the same time. And actually, I think the best thing is to use the Python Future org library. Maybe you're familiar with this. This gives you a lot of whatever you said, but on a much higher level. So there are 1,000 tests on it. And instead of making your own kind of compatibility layer, just use this library, and they take care of a lot of details, including rearranging the standard library imports and stuff like this, which can be very, very useful. So you pretty much write Python 3 code that also runs on Python 2. So on Python 3, nothing changes, but on Python 2, you get all this compatibility stuff in there automatically, which is very nice. And I think it's a good solution.
Yeah, that's fantastic. In 2020, coming up, there's going to be no more Python 2 support.
Yeah.
And that seems like that's way in the future. It seems like there could be a science fiction show set in 2020, but that's like 3.5 years away.
Yeah, I still remember 10 years ago, actually like yesterday, so it's not a long time.
Yeah, that's right. Let's dig into some of the topics of your tutorial. You started out by saying there are some general guidelines for measuring and understanding performance.
The first thing is it's the execution. How fast is fast enough? So the question is, do I have a case in the first case? So do I need to do something? And that's a lot of things. Just look at your system and say, do I need the performance? What I'm going to do with it. It's a one-way thing, and I'm going to throw away. Does it matter if it runs half an hour, 1 hour, if I throw it away? So if spend another day improving it just to be half an hour faster and never use it. Like the scientists write a lot of one-way, just moving data from here to there or something. That could be the case. Or the other, you have to have some realistic use cases. Is this really too slow? What I'm going to do with it? Those kind of questions. Seems very common sense, but actually most of the things are common sense. You just need to think through. Do I have a case? Do I need to improve it? And look through. And then again, as I said, if you're in a web application, maybe it's a database. Check how fast the database is, the network connection. Is really Python. Can you gain anything out of it? And how much can you potentially gain? So sometimes you can say, okay, I can gain not more than 20% anyway. Is it worth the effort? If they pay for the CPUs and you use a lot of CPU, maybe 20% is worth the effort. If you just wait overnight, and if it takes 6 hours or 7 hours to calculate, so scientific calculation can easily take this long. It doesn't really matter because it runs overnight. It doesn't matter if it's finished in the morning. It's fine. So those kind of things is very common things. So those things you need to maybe reiterate after a while, then you do something if you have a case. That's the first thing.
Right. And then the next one you said was sort of the whole story around premature optimization. Like, don't optimize as you go. Write your code in the most understandable way so that it works, and then think about performance, right?
Yeah. Yeah. First make it right, then make it fast. That's very important.
Yeah. Yeah. And the make it fast part is all about the measurement. Yeah.
Yeah. The first thing that I really focus here on the measurement, how to measure. There are several tools out here. I use most of the time cProfile, which comes with Python, which is a good tool. The other tools now actually are Intel is doing a big thing now, just to have this beta stage kind of profiler, which is probably quite a bit better, because when you measure something, you always influence your system. There's no way out of it. So the question is just how much you influence the system. If it's 1%, it seems to be okay. If it's 100%, it doesn't sound really right. Yeah. So, and you don't know. The question is, you don't know how much you influence the system most of the time. And then you want to have some kind of a profiler that doesn't interfere too much with your things, especially when you measure time and things are very short, then the timing might be too coarse to give you some reliable results.
Right. Or the overhead to time, very, very small function calls might be 10 times the cost of the function calls themselves.
Yeah. And that's kind of tricky how to do this, how to measure this actually.
And you can't avoid this, right? This is sort of the Heisenberg uncertainty principle kind of it behaves in one way until you observe it, then it behaves in a different way. So it seems really important to me to just look at the difference, to measure one version, change your algorithm and measure it again, rather than try to just poke at it and say, well, I ran this test and now this is slow, right? This portion of Talk Python to Me has been brought to you by Rollbar. One of the frustrating things about being a developer is dealing with errors. Relying on users to report errors, digging through log files trying to debug issues, or a million alerts just flooding your inbox and ruining your day. With Rollbar's full-stack error monitoring, you'll get the context, insights, and control that you need to find and fix bugs faster. It's easy to install. You can start tracking production errors and deployments in 8 minutes or even less. Rollbar works with all the major languages and frameworks, including the Python ones such as Django, Flask, Pyramid, as well as Ruby, JavaScript, Node, iOS, and Android. You can integrate Rollbar into your existing workflow, send error alerts to Slack or HipChat, or even automatically create issues in Jira, Pivotal Tracker, and a whole bunch more. Rollbar has put together a special offer for Talk Python to Me listeners. Visit rollbar.com/talkpython2me, sign up, and get the Bootstrap plan free for 90 days. That's 300,000 errors tracked all for free. But hey, just between you and me, I really hope you don't encounter that many errors. Loved by developers at awesome companies like Heroku, Twilio, Kayak, Instacart, Zendesk, Twitch, and more. Give Rollbar a try today. Go to rollbar.com/talkpython2me.
Yeah, that's very, very important to compare to something. Okay, that's this version. This version, the difference is very small, but this version is twice as long. Why do you spend so much effort to make it just a little bit faster? Maybe it's not worth it. It's much easier to understand shorter version than a longer version, and I gain 10% and just say how often is this called and what does 10% mean for my whole application.
Right. Absolutely. You've gone through and you've measured it. Now you've decided, okay, it's time to make it faster. And you had some really good advice that you probably shouldn't start trying to make it faster before you have good test coverage, right?
Yeah, that's a big problem, especially with scientists. So even though science is supposed to be reproducible, test coverage is not something that a lot of scientists use. You cannot generalize this, but very often a lot of scientists, depends how much they program, they might not even use version control in any way or something because they're not aware of it. Some people do, for sure, but some don't. And also, they don't know about measuring means just run it and look at their results and say that's right. So when I say tests, you want to have automated tests, so something that you can reproduce later on. And that's a bit of a problem in the scientific community. Depends where you are. Some scientists do this, but some don't do it all. And then if you try to increase the performance, you change your code. And when you change your code, you might change behavior. And you don't want to change the behavior. You want to have the same result at the end, but just a bit faster.
Yeah, absolutely. You don't want it to be really fast and wrong. That would be terrible.
Yeah.
But I think testing scientific results can be super tricky, right? You change the algorithm and you've got floating point cutoffs and different, different heuristics, and it might still model the thing correctly, but in a slightly different way. And so you can't just do like a old value equal new value sort of analysis, right?
No. You need some helpers. So you need to do something like NumPy provides a few helpers. NumPy is a package used in scientific computing quite a bit. And they have offer some helpers to compare arrays with some tolerance. So you can say, I want to compare, the tolerance can be X. So it doesn't have to be exactly the same. There can be small deviations, which is totally normal if you do numerical calculations. And you do a lot of them, then there will be some small differences. Those kind of things. There are some tools there that make the work easier.
Yeah, I think there's a couple of really interesting speedups that you talked about. And one of them, I'm sure it's obvious once you know about it, but depending on your background, where you're coming from, maybe you just have no awareness or it's not on your mind in terms of thinking about performance, but alternate interpreters or runtimes, right? Like under certain circumstances, you might be able to switch your code from, say, CPython to PyPy and get pretty serious performance improvements, right?
Yes, that's true. So PyPy can be very nice, especially for numerical computations for loops. And when you write a for loop in pure Python and you use only integers or floats in there, typically PyPy can find this out and just make it faster. So it compiles it to machine code in the background. Very often you get close to C speed. So somewhere the range of C speed, then writing the same loop in C, which can be easily factor of 10 faster or even more than pure Python.
Yeah, so if you need a 20% speed up and you can get your code right on PyPy, maybe you're already done, right?
Yeah. Very likely you're done. PyPy, of course, they have this benchmark, and I think it's a very big benchmark, and they factor 6.5 times faster. So that's way more than 20% for average benchmark. There might be, I think they don't have a single one where they are slower, actually. The first thing, they just get the same thing. So as soon as you have a problem, it's not going to work for something like Mercurial, where the time is in starting the interactive program. So of course PyPy, I think it's slow in startup. It works for things that are computationally expensive and will repeat it many times. If you do something only twice here and there, PyPy doesn't have any way to do it. It has to be done like 10,000 times, and then PyPy says, okay, it's doing always the same thing. I can compile this one to machine code, and then you can get a speed up, which is pretty close to C. Actually, they had this one contrived example. PyPy was faster than C because PyPy managed to inline some function calls where C just was statically compiled and called some library functions. And though PyPy was a bit faster than C, which is, of course, is pretty contrived, but still you can get close to C.
Yeah, it's really cool to see those examples, though, that that's a possibility, right? And if you use it in the right circumstances, very cool. Let's suppose we've decided that we need to make our code faster, and just to keep the conversation a little bit simpler, let's say we'll stick to CPython for whatever reason. So you talked about a couple of tools that we can use to understand our code, and a variety of them. The first thing you talked about was this thing called Pystone. What's that?
Yeah, Pystone is just a benchmark, a simple benchmark. And benchmarks are always wrong in one way, because benchmarks are designed to measure some kind of performance. But maybe they're better than us. And Pystone comes with Python. So it comes with the Python standard installation. And you can run PyStones, and this gives you a feeling of, because it's pure Python, so it runs with CPython, with PyPy, with JSON, with IronPython, whatever you want to test it with. And you can see how fast the Python installation is. And of course, it's also connected to your hardware, but if you run it the same machine, then you get a PyStone. You can also have this kiloPyStones or something. Can, of course, get you a big number, but also gives you time. The bigger the PyStones, the better, or the shorter the time, of course. And you can see if you run this over this PyStone, you can have a very rough comparison of different Python interpreters. And of course, if you run on different hardware, the hardware will be included in this thing.
Right. For example, if you're working on your dev machine, but then you have some big virtual machine in the cloud that you're actually going to run your code on, you could say, well, if it's taking this long here, and I can compare the PyStones from my dev machine versus production, then you get like a little bit of a sense for the scaling factor up or down, right? Yeah.
So it's pretty controversial if PyStone is a good benchmark. So it's one of the benchmarks. If you want to, you can take other benchmarks. You could go for the PyPy benchmark and see how this works, or other benchmarks around to run it. But the thing is simple because it's there. You don't have to go and make it work because it's supposed to work with this part of the standard library. And as far as I know, it works with JSON, it works with IronPython, it works with PyPy, it works with CPython from the old to Python 2 and Python 3, everything. So you can get a feeling how fast your Python is.
And then the next thing you talked about is using cProfile to measure your code.
A bunch of profilers around. One of them is Profile, which is written in Python, which has a lot of overhead, so it's not really recommended. And cProfile is, as the name suggests, written in C, so the overhead is much less.
But it only works on CPython, right? It won't work on something like PyPy, will it?
It works only on CPython. So okay. I focus this on CPython because it's more about the principles than about the tools. In particular, I would say just get people kind of a workflow how to do this. And if you have a different setup, you might need to use a different system. Like if you work on JSON, you might use some profilers that Java gives you or something. I'm not an expert in this field, but the procedure is the same. So you want to measure. And my caution is always those tools can be wrong. Sometimes you get strange results, and you always have to question it. But you might find a second or third way to measure pretty much the same thing. And look if the results correspond somehow. If you get totally different results with different tools for the same kind of measurement, then there must be something wrong with the tool or how you apply the tool. So maybe you just use it in the wrong way.
Right. Or even there's some really crazy overhead, like you're calling a function a million times, but the measurement of it is so much larger that it's just completely out of whack, right?
Yeah. Mm-hmm.
Okay. And so if I had like some method and I wanted to profile this, what's the steps? Like what do I do with cProfile to get this rolling?
So first I show the slow way to do it just with the standard library. So it's just import cProfile. You have to make instance of a class profile, and then you have several abilities or several possibilities how to call a method. You just can put the method in with arguments. You can also use a string, evaluate a string, and then as Python code and get the results. And then you get an object that represents the results, and it call different kind of print or other evaluation methods on it, and it shows you the results. The cProfile only goes by function. So the finest resolution, you see how much time it takes to run one function call. So it shows you how many times a function being called, how long it took per call, and how long it took in total. You have a lot of ways to sort this by the most calls, the longest times. And you can also sort who called whom. So you can have a relationship, this function called these functions, and you get some kind of a graph there.
Yeah, okay. Yeah, that's really nice. And then you also use Jupyter Notebooks to do some cool stuff there.
Yeah. So if you find it easier, so a Jupyter Notebook is actually the killer application of Python, I would say. Because it's Jupyter Notebook, they have what's called %p run, which is kind of a wrapper around cProfile. There's no new functionality in this case, but it makes it much more convenient. So instead doing 3 steps, importing, making instance, you just say p run, and p run takes some like command line arguments. So you can specify how many times you want to repeat or whatever you want to do. And then it runs your function call and gives you all the results in the same way, which is very nice. So that's, if you use the Jupyter Notebook, used to be called IPython Notebook, but nowadays it's Jupyter Notebook. You should use it anyways. No matter, it comes from the scientific field, and it's used a lot. So if you go to a EuroSciPy or SciPy conference, pretty much everybody's using a notebook. But it can be useful for everybody who's programming Python just to try something out. And this profiling means to try something out, try something again and again. So the new notebook is great for this. And this gives you pretty much everything you can do with cProfile, just much shorter and much more convenient. And if things are shorter, then you're more inclined to do something. So if it makes it more convenient to do something, then you will do it more often and you measure more often, I would say.
Yeah, the easier you can make this and the more automated you can make it, the more people will do it, right? And with Jupyter Notebooks, you can go back and you see the cells that you ran before and you just kind of like rerun them again if you want to retry it. And yeah, it's really nice. Yeah.
And then of course, you get a table output, but then you say, a picture says more than 1,000 words. There are some nice tools to actually visualize it. And I use this one called SnakeWiz. So you just run SnakeWiz on the output. So the cProfile, you can store all this profiling data in a file. I think just Marshall just put there. And then you read it back with SnakeWiz, for instance, and it gives you a nice picture. So you can look in the browser and it's an interactive thing. So it's running this file is interactive. So you can zoom in and look at different things and gives you everything in a nice, colorful picture, which is pretty helpful because you can see in a part of a second what's going on. What function takes most time. So you can look at it and then you can click on it and you have all the information. It's nothing different than the table. But if you have a big table with a lot of numbers, it takes you a lot of time to make sense out of it. And this diagram you get there, it's much more convenient to use.
Yeah, certainly when you have tons of data on almost anything, like having a really fantastic way to slice and dice and visualize it makes all the difference. And this SnakeViz is really cool. So the way it works is basically you run the profiler and instead of printing out the stats to the terminal or something, you save them to a binary file. And then this SnakeViz can like suck that up and it runs a little local web server that then opens your browser and you cruise around in there, right?
Yes, yeah. It's very nice. So you have the table, and you can also sort the tables in there also. So you have the raw numbers if you want to, but you also have this picture, and they have two different ones. They have one is a circle, like the outermost function is innermost circle, and that's going outwards, and you see the circle is getting smaller and smaller, like fractions of a circle. It's very nice visualization. The other one is called icicle. So instead of a circle, you have squares of areas that are, or not rectangles actually, stacked on top of each other, which also kind of symbolize this function is calling this function. You see where the time goes.
Yeah, that's really cool. And I think, if you have a program that you care about performance, run this through it really quick and just look at the picture and you'll probably learn something right away, I would think.
The case is if you see one big function that uses all the time, then you know where to go. If it's very evenly distributed among a lot of functions, then it's much harder because where are you going to start? You have to look at all these functions at the end. So that's the first thing. You see, you have a case. If you see, okay, all the time is in this function, then it's very worthwhile to look at these functions. If you have 20 functions, so they all take about 5% of the time, yeah, we're going to start. So it will be much more work to work through all these functions.
Right. It's not just low hanging fruit, but it's something different, right? So that's CPU profiling, and one of the ways your code can be slow is it's just computationally expensive, or you could also discover, I guess, external things that are slow. It could be, the cumulative time for like a disk IO or a database call or a web service call could be really large, and that would tell you that thing is slow, right?
Yes, yeah. Actually, you can do the cProfile. cProfile typically measures wall clock time, so the time that actually elapsed from the beginning to the start. But you can also provide your own timing function. And you could do something like CPU time. So CPU time is really the CPU spends doing something. So if you use something like time sleep in your code, say time sleep 2 seconds, then the wall clock time will be 2 seconds, but the CPU time will be nearly 0 because the processor is not doing nothing actually, just waiting for you to do this time sleep. So it is very important to see. So if you do input output, you wouldn't see it. You wait for something that it happens, and time sleep just lets the processor rest in terms of your process. Of course, the processor is still working, but not for your process, not what you're measuring. And that's an important thing. So that's what I try to get across, that most of the time you measure wall clock time. Unfortunately, there are differences between Windows and Unix systems. Especially in Python 2, if you just use a time.time, which gives you a timestamp on Unix, which is nice. On Windows, it's way too coarse to do anything useful with it. Therefore, you should use time it default timer. That's something I always like to get across, because very often you see a lot of online tutorials that use time, which is totally fine on Unix. But if somebody is trying this in Windows, they might not get useful results because it's pretty coarse. And also there's a time.clock, which is much faster on Windows, means measuring time on Windows, but measuring CPU times on Unix. So it's pretty messy here. So you might mix things up. You might measure the wrong thing depending on your platform, which is not good. And therefore, I give you like a small helper function that gives you also the CPU time on Windows.
That's completely not obvious that the time is a value-weighted difference and sometimes even means something different on the different platforms.
Yeah. Actually, I think it has a reason because it's just a thin wrap around the C library. The C library is different on the platform. In Python 3, it's better. There's a time perf time, I think, which kind of abstracts this away a little bit. So it's getting better. So another reason to use Python 3, so you have a better abstraction of this platform abstraction of this measurement.
Continuous delivery isn't just a buzzword. It's a shift in productivity that will help your whole team become more efficient. With SnapCI's continuous delivery tool, you can test, debug, and deploy your code quickly and reliably. Get your product in the hands of your users faster and deploy from just about anywhere at any time. And did you know that ThoughtWorks literally wrote the book on continuous integration and continuous delivery? Connect Snap to your GitHub repo and they'll build and run your first pipeline automagically. Thanks SnapCI for sponsoring this episode by trying them for free at snap.ci/talkpython. So that lets us measure things like web service calls and databases as well, which is really interesting. But sometimes it's more of a memory pressure or a memory issue. Like maybe the reason our code is slow is because actually we're running out of memory and it's like going to page on memory on disk for the virtual swap files and all that kind of stuff, right? So can we profile memory as well?
Yes. Profiling memory, it's not the simplest thing, but there are some tools out there. And I used to use Hippie, which is part of this Guppy project. But as far as I know, it's only Python 2 so far, if I'm not mistaken. But there's another project called Pimpler, which is also a merge of 3 different projects in the past. And this supports Python 3. They do pretty much the same thing. And if you have the chance, actually, you can use both of them to compare the results, which is always good.
Yeah, I saw Pimpler, and that looked really, really cool. That's Pympler, right?
Yes.
Pimpler. Yeah, so Pimpler is really easy to use, actually. I mean, it's computationally expensive because traversing the entire memory structure is not cheap, but you just basically import this thing called tracker, and you say summary tracker, and then you can just later ask for a diff, like what has been allocated or deleted since then,
yes.
Right?
Yeah, so it gives you a kind of the diff, what happens, and it gives you a diff according to data type. You see so many strings, so many integers, so many floats, so many other types. You can see it. And if you call it several times, you should go to 0. You will see if you call it the second time, you still have a few kilobytes here and there sitting. If you call it multiple times, you will get close to 0. So I always stress measuring memory is not something you can measure a byte. It's more about getting the megabytes. So you want to have a big picture where the things are also not totally accurate, but if you have a lot of megabytes, then the error is small. And so actually I wrote a small decorator helper so you can put a decorator on your function and you can see if your function is leaking memory. So you measure the memory usage before the function call and after. And if you have a function that kind of like appends to a list, a global list or something, then you will see how the memory usage increases. If you just do something in the function, you just return and you don't store the return value, that the function shouldn't change memory. So it's kind of simple things. You get a feeling what's going on. And it's always good because Python is easy to write a decorator or something. So you can write your own tooling that is totally tuned to what you want to do. So you have these basic tools, and then Python makes it so easy to write some nice special tools for your use cases.
Yeah, that was really cool. And I really like the way that you're using decorators in your tutorial. Like here you have one called measure memory or something like that. So you want to measure some function and all the functions it calls, of course. You just say at measure memory in front of it, right? And then you get this little summary, which is really cool. Yeah, so I guess if you want to answer the question of how many bytes is this, 5 or 10 byte thing I've created, like this wouldn't be the way to do it. This is a way to get like large scale pictures of oh, I have 10 million integers and I didn't expect that. What's the problem, right?
Yeah. Mm-hmm.
But there's also ways to like actual get object size from this library, isn't there? Like,
yeah.
difficult to know the full like closure of an object graph's size, right?
Yeah, you can use this get size of. The sys module in the standard library has a size of, which gives you the memory size of one object. But it's only the object itself. Like you have a list, you get the size of the list. But you don't get the size of all the objects stored inside the list.
And the objects that they store and the objects that those objects store, right?
And so on. Yeah, Pimpler's giving you this so you can actually measure. And actually I have a very nice example. They're very interesting. So I start with an empty list, and then I keep appending to this list one integer after the other, up to 1 million or so, 10 million actually. And then every time I append, I measure the size of this object and see how it changes. And I use two different ways. I use this kind of built-in sys get size of, which gives you just the size of the list. And then the other one from Pimpler that gives you the whole memory, the list and all the integers in my case use up. And you can see a very nice step function because that's how Python actually works. So you have a list and Python always allocates a bit more, roughly 50. There's a formula, but roughly 50% or so more memory. It fills this memory. And then when it hits the limit, it allocates more and more. So if I have 10 million appends, I get like 104 or so allocations, which is because allocations are pretty expensive in terms of time. So this makes lists so efficient if you do append. If you use some other structure that would need to be rebuilt, or if you use, instead of appending to a list, you insert 0, so you insert at the beginning of a list, that means every time you do this, you have to rebuild the whole list and you have to allocate all the memory again, which is a big anti-pattern actually. So, and it's very nice. You can visualize this. Why is it like this? And you can see a picture. And I think it's always, if somebody tells you that's the case, it's one thing. If you do it yourself and you measure yourself, it's a very big difference in terms of experience. You see, okay, I measured it myself and I can play around with it and see how things change.
Yeah, I thought the graph was really cool because it made it very clear what the algorithm was. You can see that it's basically trading a little bit of memory for a lot of performance.
Yeah.
And in the general case, right? In the general case.
Yeah. Now, if I say you can buy memory, so buy a bit more memory, just costs you a few bucks. But making your CPU 1,000 times faster is pretty hard, I would say.
Yeah, absolutely. So the other thing that you showed in your tutorial that I thought was really cool that I don't think we've touched on yet is line-by-line measurements. So you could do line-by-line CPU profiling as well as allocation management, right?
Yes. Yeah, you can do this. So there's a line profiler from Robert Curran. It's an author, and actually he ported it to Python 3 now because I asked him several times to do this. And now the line profiler works with Python 3, it gives you a lot of overhead, so it makes your program much, much slower, but gives you a line-by-line breakdown because the C profile is just the smallest increment you get as a function. And you can do now line-by-line profiling, which is especially important if you write a function and you have like calls to NumPy. So in a function, you might have 3, 4, 5 calls to NumPy. Then you can see which call takes the most time, for instance.
Right.
And this is what the line-by-line profiling is doing.
Yeah. So maybe you use C profile and those sorts of techniques to go and figure out, all right, well, I know it's really this function that is a problem, but it's 10 or hopefully not 1,000. It's 10 lines long. What's actually slow about that, right? Then you can turn on this line profiler business, yeah?
Exactly, because you only want to have 1 or 2 functions. You use a decorator, add profile. You put a decorator called profile there, and then you run it through your profiler with some options. This line profiler, and then it makes it very, very slow. So either maybe factor of 100 slow or something like this. It feels very slow because it just has to go line by line and has to check everything what's doing. And gives you a nice breakdown. You see, okay, allocating this list or this array takes so much time, and then looping over it takes so much time, and doing this takes so much time. So you could see pretty much where the time goes, which can be really useful educational. So you just get a feeling what these functions are doing, but also useful to make your program faster.
You also talked about some anti-patterns, things that you should try to avoid or,
Yeah.
Can you go through a couple of those?
Yeah. One is I just said is about, maybe the most important one is about a list. So if you have a list, then you want to append at the end, and maybe when you're done, you just reverse the list if you want the other way around, instead of inserting at the position 0, which is what you want in the end. This would be a big anti-pattern, and this can be many orders of magnitude difference in terms of performance if you do this one. And this is one of the biggest anti-patterns. Another anti-patterns is like string concatenation, which is an old one, which it's now kind of optimized in CPython. So instead of saying string plus equals new string, string plus equals new string in a loop, you just use a list and append to the list. Take advantage of this list behavior. And then at the end, you just join the list.
Yeah, because the lists do this pre-allocation thing where strings don't.
Yeah, so this is actually, it's not really true anymore. It used to be in the beginning of Python. So I started with Python 1.52. This was my first Python version. And that was pretty true, I think. And then pretty soon they changed, they optimized it away. And it works with CPython. But if you use PyPy, which is supposed to be much faster, then this anti-pattern just kicks you. Then if you do this for a string of, like, say, 100,000 characters, it just kills the performance, and you have to wait an hour or so instead of a second.
Wow.
So I remember I just read it somewhere. There's a reason they didn't put it in this optimization. So you never know if CPython always can optimize it, because for simple cases where I use string literals and stuff like this, it should be easy. If it maybe is a code a bit more complex, who knows if it's still doing the optimization. So it's better not to rely on this. As long as the string is short, it's fine. But if it's get a bit longer, then
yeah, it's a problem. Maybe you're streaming stuff out of a CSV file and trying to build up a thing, and maybe it can no longer optimize that. Who knows, right?
Yeah, who knows? You never know.
Another interesting example you had was looking, sort of optimizing variable and function lookups, like caching global things like square root versus math.square root, for example, in a function.
Those kind of things. So it depends what you're doing. It can give you a little bit speed up. So because that's just the basic thing how Python looks up names. So first looks in local namespace in your function, then goes to the global namespace, which is your module, and then goes to the built-in namespace. And every lookup is kind of a dictionary lookup. And instead of going like to the global, even the built-in namespace, like if you use sum, the built-in sum, then every time you use sum, Python has to go and hunt for sum until it finds it. And so if you say, okay, my sum equals sum in a function, for instance, then you make it a local variable and you avoid like 2 lookups for every time you use sum. This can be useful.
Yeah, if that's in a tight loop, then maybe that becomes a problem, right? Or a loop within a loop.
So if it's a tight loop, you don't do much else, then might be something. If you do a lot of very other heavy computations, or the sum itself takes a long time to sum something big, then you still get the speed up from the lookup avoidance, but percentage-wise, it might be just 0.5% faster. It might not make a lot of difference. If you don't do much else, you can get several 10% faster behavior or something like this. So it depends very much on your use case, but at least you can try, and this would be one thing. So if you call a function or some built-in or global variable in the inner loop again and again and again, making it local might speed up things a bit.
Sure. You had a cool example where one of the points you were making was saying, look, sometimes it's an algorithm and you just need to look, not optimize a function a little bit, but you need to rethink how you're doing something. And you had this, it was a contrived example that was computational, but you were basically computing pi using the Monte Carlo method. And you said the naive way to do this would be to sort of generate a couple random numbers, do some math, save some values, and do this in a loop. And you said, well, look, if we do this with a different algorithm, like using NumPy, we get dramatically different performance, right?
Yeah. So NumPy, so the algorithm, this Monte Carlo algorithm, is maybe the worst algorithm to calculate pi. There are much better algorithms out there. They give you pi with 100 digits with 100 iterations or so. So with Monte Carlo, 100 iterations would take the age of the universe to calculate, I guess. So it's computationally, but it makes a good example because it's very slow and you can use a lot of techniques to improve it, because also it's embarrassing parallel. So I use it later on, actually do some parallel calculations with multiprocessing and other means. So it's a very good example because I can use the same example with many different kind of approaches, which is useful. So it is simple enough to understand. So I use this and then you just run it in normal Python. And as I said, one of the things where Python is slow is when you do numerical computations and you use 4x in range, 4y in range loops, something like this. This is pretty slow. And if you just use NumPy, and NumPy is doing this vectorized, so instead of writing a loop, then you just call a function in NumPy. That's actually when you program NumPy, you should pretty much never write a loop. You should always vectorize things if you want to make it fast. And then NumPy just runs it through the function which is running in C, and you get near C speed for a lot of things. So it makes it much faster.
Yeah, that was really cool. I like that example. what if people missed this, right? This was actually done in June. So if they weren't there, they've already missed it. There's a couple opportunities to still check out your presentation though, right?
Yeah, the presentation does, you can go to YouTube. If you go to PyVideo, it's on YouTube. If you search for it, you will find it. So if you go to the PyCon US site, then it should be there. So if you look for faster Python.
Yeah, and I'll link to it in the show notes as well.
Yeah, you can link to it. And also I will give this tutorial again at EuroPython and just in a few weeks in Bilbao, in Spain. So then there will be this tutorial again. So I will talk about it.
Yeah, EuroPython's going to be very exciting. That'll be a good conference.
Yeah, it's a nice conference. I gave it last year there. So it seems like because there's always demand for it and people liked it. So it's just because I try to always make it hands-on so you can follow everything. So nothing is too sophisticated, which is on purpose, because if you show too sophisticated code, people won't understand. So everything is pretty simple and you can use it right away. And hopefully when you understand, you can apply it to your own use case. That's the whole purpose of the thing.
Yeah, that's great. So we just have a few minutes left in the show. Before we call it quits, let's talk a little bit about what else you have going on in the Python space.
I've been in the Python space for quite a while, since 1999. Actually, I spent my professional life in the Python space. I teach Python. So I'm the founder of Python Academy, which is now more than 10 years old, actually. And that's that I teach Python. I gave my first Python course in 2004. It's quite a while ago. So I taught university level courses in different fields, my scientific fields. So I had some experience in teaching and gave a lot of talks at conferences. There was just a small step to Python courses. So just how it developed. So I really like teaching. It seems like that fits. So people understand most of the time what I'm saying. And so I started teaching Python. And meanwhile, Python Academy grew. Now we have about 11 teachers. So not everybody's teaching all the time, but I have a lot of different teachers doing web development, testing, Python, database programming, and I have also teachers that have different native languages. So I myself can teach in German, which is my native, and in English. But I also have people teaching in Italian and Polish and maybe in other language later on. So some people might be taught in their own native language, which might help to understand.
Yeah, absolutely. And congratulations on the success there. That's awesome. I've been deeply involved in training companies for the last 10 years myself. And I know what it takes to put those together and keep them running.
Yeah, it's a lot of effort. So myself, so Python Academy, we focus on everything Python. So very wide range in terms of Python, but deep in there. So I teach beginners, people that barely programmed before, or other programmers, so professional programmers that want to switch to Python, and also advanced Python. I have advanced Python course. But that's a Python track. And also teach scientific tools, which is a very wide field. So I teach how to use an IPython on Jupyter Notebook and NumPy and some SciPy tools and Matplotlib and Pandas, those kind of things, which is in very high demand because scientists need these tools all day long.
Yeah, absolutely. What's your favorite one to teach?
Depends. So I like to have variations. So I like the scientific thing, and actually, but I typically like in a course I like to include an example from the people and actually do a little bit live programming in the course. So they have a problem and say, okay, scientists very often they have to read in this file A and have to convert it into file B, which is a very common thing. And Python really shines on this. So you can actually in the course ad hoc develop a small routine and read in the file with different tools. So you can do it with just standard library. You can use Pandas, which is great for CSV files and something like this. And then you say, okay, now I have this file and I search the data and then I write it back somewhere. And this is very often very useful because then I can use a lot of things I taught in the course. So how to do this, how to write a function, how to write a docstring in a function, and how to make a function, refactor the function because it's getting too big. Everything, but on a small scale, so understandable for people. And they see it's really useful if you do this. So if you can reuse this function again and again, do something. That's mainly for scientists. That very often scientists use programming as a tool, but they're not so deep into programming very often. As compared to professional programmers, for them, there's nothing new, though they pretty much understand when I say something, they understand the concept, and that's pretty easy. You can go on. For scientists, you have to give an example because just explaining it in these very kind of generic examples might not be kind of really good enough to understand what can be useful for.
Right, because they spend most of their time working on physics or biology or something real, right?
Yeah, something real. So it depends. Some of them tend to become programmers. Very often scientists turn programmers, but many of them just use Python from time to time as a tool, as an important tool. And as soon as they get their result, they just forget about it and go on. Then I said, wait a minute, you can now. The script works, but if you spend another half an hour, you can make it reusable. And next time you can save a lot of time because you put this in a function and you put a long string. And maybe you put a test in there. So make it work, and it makes it much more useful. Even your colleague might be useful. Now, if you write this small function or several functions that can read this file format, then your colleague can use it. If you just have a script that's doing everything in one piece, then your colleague is probably not really able to use it without a lot of effort.
All right. You end up starting from scratch every single time.
Yeah. So it's kind of, it depends. Yeah. So that's what I like. I like the variety. So I like introductory courses, even though I taught it many times, but also like the advanced course. And lately I had a course where people really used meta classes, and I had to really dig deep into meta classes. There were some very hard meta class questions. I had to kind of think really hard because meta class is a bit esoteric topic.
Yeah.
But most of the time, it's, if you don't know what they're doing, you don't need them, and then you could stop the course. But sometimes they can be useful for certain types of things, and these people really use them to high extent, which was interesting. Pretty challenging course, though.
Yeah, cool. Yeah, it's great to have that spectrum. Do you also do consulting?
We also do some consulting. So actually, I do some scientific consulting. I just helped them develop some lake model. So we do some consulting in scientific area. Of course, not only me. So we have a team of a few people. So we also do consulting and program something. And sometimes you also connect the consulting, actually pretty frequently. So develop a solution, but instead of handing over a black box solution, we do a workshop with it. So we explain how things work and how people can extend what we did. So you get a really solid solution, which is people probably like scientists would not be able to write themselves, but they can build on it. So they have this basics, this good foundation, you can build it and can use it and increase it and make it more useful for their needs.
Yeah, that's great. That's really helpful. And then finally, you've done a lot with conferences, like you were involved with EuroSciPy, EuroPython, and so on, right?
So it seems like I'm very much into conferences. So actually, I started I was the guy behind pushing EuroSciPy. So I started here in Leipzig, where I'm located. In 2008 and 2009, the first two EuroSciPys happened here, and I was the chair. And now EuroSciPy has a great success. Then we had two conferences in Paris, two conferences in Brussels, two in Cambridge, and now we're back to Germany in Erlangen. It will be in August, so just a little bit more than a month from now. That will be the number 9 EuroSciPy. So it seems like a success. People come to the EuroSciPy, and it's continuing. So I've been involved in EuroSciPy, and also I'm involved in PyCon.de. So 2011, 2012, PyCon.de, the German PyCon, was here in Leipzig, and I was the chair. And also PyCon.de is run by the Python Software Verband, which is a kind of a German Python software association. And I happen to be the chair there also. So I'm a bit involved in this community work. And then we also did EuroPython 2014 in Berlin, and I was also the chair, which was a big conference, more than 1,200 people.
Yeah, that must have been a lot of work to put that together.
Yeah, so we had a very great team. So, of course, you're the chair, you just kind of oversee everything and try to delegate as much as possible, which is necessary because it's just impossible to do main part of the work yourself. You have to we had a great team, and we had a lot of people that are very enthusiastic about it and put a lot of effort in there. And it was a great conference. I had a lot of good feedback from people about the conference.
Yeah, cool. Are you involved in any upcoming ones?
Yes, I'm at the EuroSciPy. So the Python Software Verband is also taking over the legal part of the EuroSciPy. So we do somebody has to move the money and sign the contracts and stuff like this. So I'm involved there also, and we use the software that we use for PyCon.de and EuroPython for EuroSciPy now, the web conferencing software. I'm involved there, but I'm also a little bit involved. We have what's called the Python Unconference in September, and our software Verband is sponsor, and we help and support a little bit. So we are not the main organizer, but we help. There will be likely, so we are very close actually. There will be a PyCon.de in October in Munich, and we are involved there. And there will be next year PyCon.de and the EuroSciPy next year also. So, and I'm always involved to some degree in these conferences. I'm not doing the main work for sure, but I'm on the mailing lists and I'm somehow involved in organizing.
Yeah, that's cool. It sounds like there's a lot of conferences coming up in Germany around Python. That's cool.
Yeah, there's several of them. So we have this Barcamp. which is interesting in Cologne. I myself, I'm just a participant. The other people do this, which is pretty relaxing. So it's a kind of also like an unconference. So we have this unconference in Hamburg, then this Europe. So there's several events we have. So now actually we have not this one big one, but multiple smaller ones, which are more regional, which can also be nice. So because people don't have to say, if I miss one, then it's it. I have still 2 or 3 more alternatives.
Right. A little bit of each is really great. Final 2 questions, Mike, before I let you go. When you write some Python code, what's your standard editor? What do you open up to code?
Typically, I go with Sublime nowadays. Sometimes I use Wing IDE if I have some projects, which of course has a nice debugging and refactorization things. For courses, also you use Spider, which is kind of a scientifically inclined thing. So of course I use it for my courses.
That's the one that comes with the Anaconda distribution, right?
Yes, so Anaconda has it out of the box. If you just install Anaconda, you have it. So Spider, it's not perfect. It sometimes crashes, but it's okay. So of course, the nice thing is you don't have to tell people to install a different editor, just to have one. And they have a debugger and they have an object. You can look at the objects, the Python objects for debugging and stuff like this, an interactive console if you like. But most of the time, in course, actually I spent in Notebook anyway. So
right, yeah, the Jupyter Notebooks is also really nice. That's cool. All right, and the 80,000 plus PyPI packages, what's your one to recommend that people maybe don't know about?
The one that we talked about already, the Jupyter Notebook, is the killer app. So if you don't know Jupyter Notebook, you're missing something out in the Python community. That's something you should go. So it's very interesting to work with Jupyter Notebooks. I always have a notebook open to just try something out. If I have an idea, you can use it. It's a very nice mixture between an editor, a full editor, and the interactive prompt, and that makes it. Maybe that's not a real secret. The one I'm looking right now is Sconch. Sconch, Sconch is this interactive shell.
Yeah, with an X.
Yeah. There's an X, but it's pronounced Sconch. And I know Anthony Scoparts pretty well. We were hanging out at PyCon lately, and he's a funny person and very, very knowledgeable on top of it. And he wrote a very interesting tool which gives you a kind of a shell that incorporates Python. So in a nutshell, so it's very interesting. So you get a shell that incorporates Python, and then I think it works on Windows. So you get a much more powerful shell on Windows, because the shell on Windows is typically not that great. So if you need to work on Windows sometime, as I do for my courses, then this would be a good alternative to work with. Right.
Yeah, that's cool. Okay, great recommendation. Yeah, and the story on Windows is getting better, right? Like Steve Dower redid the installer, so now the installer is not a complete challenge to like get Python on there. The Windows 10 shell is a lot nicer. They're bringing the Ubuntu binaries to it, Windows 10 starting in a month or two. So it's getting better, but yeah, it still is sometimes painful to work on Windows.
Yeah. But in the compiling C extension is still not the smoothest experience.
No. Let me just say VC vars bat was not found. Right?
Yeah. I had this message about 100 times. Yeah,
gosh, yes. So. All right. Well, Mike, it's been really fun to have you on the show. Thanks for sharing your optimization experience.
Thanks for having me. Thank you very much.
Yeah. Talk to you later. This has been another episode of Talk Python to Me. Today's guest was Mike Mueller, and this episode has been sponsored by Rollbar and SnapCI. Thank you both for supporting the show. Rollbar takes the pain out of errors. They give you the context and insight you need to quickly locate and fix errors that might have gone unnoticed until your users complain, of course. As Talk Python to Me listeners, track a ridiculous number of errors for free at rollbar.com/talkpython-to-me. SnapCI is modern, continuous integration and delivery. Build, test, and deploy your code directly from GitHub, all in your browser with debugging, Docker, and parallelism included. Try them for free at snap.ci/talkpython. Are you or a colleague trying to learn Python? Have you tried books and videos that just left you bored by covering topics point by point? Well, check out my online course, Python Jumpstart by Building 10 Apps at talkpython.fm/course to experience a more engaging way to learn Python. And if you're looking for something a little more advanced, try my Write Pythonic Code course at talkpython.fm/Pythonic. You can find the links from this episode at talkpython.fm/episodes/show/66. Be sure to subscribe to the show. Open your favorite podcatcher and search for Python. We should be right at the top. You can also find the iTunes feed at /iTunes, Google Play feed at /play, and direct RSS feed at /RSS on talkpython.fm. Our theme music is Developers by Corey Smith, who goes by Smix. You can hear the entire song at talkpython.fm/music. This is your host, Michael Kennedy. Thanks so much for listening. I really appreciate it. Smix, let's get out of here.
Stating with my voice, there's no norm that I can feel within. Haven't been sleeping, I've been using lots of rest. I'll pass the mic back to who rocked it best.